Okay, everybody, I'm just looking at the syllabus here to make sure everybody's on board. So remember, this Thursday, I will be providing you with a video that you can watch asynchronously, as you can anyway. So just, I won't be here on campus, but let's go ahead and get started. So really what I want to do today is I want to look at kind of a continuation of what we did the other day with mixed models. So the other day we actually looked at generalized estimating equations, and I showed you different ways to do it. And one of the ways we did it was with mixed models. However, mixed models have some limitations in that they require a normal distribution. And some of the things we were doing with the generalized estimating equations, which does not assume any distribution, was using different types of distributions, binomial, et cetera, and different link functions linking our predictors to our outcome. It actually took me a bit of time to work on this because I have to learn how to do this in SAS. And, I was using an old data set for this, and this data set was really tailored towards SPSS. So after playing with it for a while and banging my head against the wall a couple times, I said, forget it. I'm going to create my own data set for this example. So that's what I did here. Okay. So we're talking about mixed designs. Mixed designs include a mix of within and between type factors. It also has a mix of what we call random effects and fixed effects. Fixed effects are, if you think about it, basically the same outcome is, or the same parameter estimate applies to everybody. Whereas random effects, you can have differences like in effects based on something. Like sometimes we see it, well, like you'll see that there's change in an individual over time, right? So that individuals can differ in terms of change when we're looking at repeated measures. And that's kind of what we're dealing with today. Although we're not going to do the random effects here, we'll deal with that at a different time. But basically, what we're going to look at today is kind of continuing with this idea of repeated measures design or longitudinal studies. So we're going to look at this within factor here, and the within factor, when I mean within, it's within an individual, there's change over time, right? And between factors, something like a discrete predictor variable, right? So something like gender or whatever we're doing. I have a special example for us, and then we're going to do a within by between interactions. So this is similar to what we did before, but it just is kind of like continuing with this idea of mixed designs. So we're going to play around with some examples that I created. All right. So given that it snowed yesterday, although I'll tell you what, the snow was not that much here. I was like, oh God, Philadelphia is going to be miserable. Yeah, it's nothing. I think the last snowstorm we had was actually worse, although the snow is much more dense now. Snow is much more dense than what we had before. It's a lot thicker, a lot more wet, if you think about it. All right, so let's look at this example. There's a lot of anxiety about driving in snow. However, much of this anxiety may be related to one's experience and the type of car one drives. Makes sense? As such, I propose that the effect of snow on anxiety depends upon whether one lives in a rural versus urban area. So that's where the experience comes in. You might have more experience in a rural area versus an urban area driving in snow, and whether one owns a car that is built for snow versus a car that's not built for snow. Same thing of something like a Subaru Wilderness Edition that has different snow modes. We collected data on 18 individuals, half of whom experience snow during the data collection, half of whom have a snow car, and half of whom are rural residents. They're not split equally. So you may have a rural residence, but not a snow car, etc. We collected our data over 3 consecutive days, and we were looking at anxiety over those 3 consecutive days. So these are the data that are included in your spreadsheet. So you can actually download. So we're going to actually do this as a kind of the way I did it because I think it's something that can be very, very useful. So we have data that have, actually, I don't have the titles here. Maybe I do in the other one. Let's see. Hold on, let me check. Yeah, so we have subject, anxiety, snow, car, rural, and day. But this is a different data set. So we have these data here, right? I don't know what happened to the headings for that data set. I must have forgotten to do it, but it's okay because I do have this data set available for you to download in Excel. If you don't have it, because Excel and Microsoft Word are buddies, right? They're all Microsoft products. You can just copy this into an Excel spreadsheet and get going. So this was just copied from an Excel spreadsheet. So I'm going to go to our course here, and I'm going to download this data set. And I called it Snow Cars 2. Snow car like a snow car. So I'm going to download this. So it's an Excel spreadsheet. All right. I don't need to open it here, but we're going to open it in SAS. It's in my download file. So when we're downloading these data sets, we really don't need to open them, especially if they're SAS, SPSS, because if you don't, unless you have that program, or if there's Stata or something, if you have that program, you can download it, but otherwise it's going to be hard, and you want to just wait till well, I mean, you won't be able to download it, so you want to wait till you get into SAS. We're going to go into SAS, or SAS on demand for academics. So let me see. I'm going to delete everything that I have in here so I can work through this process. I just want to keep on doing this over and over again to make sure that everybody knows how to do it. So I got all these snow car data sets. I'm going to delete these bad boys. Let's see, delete. Let's go ahead so this is my sacrifice for you all. I delete them and start all again, over again. Delete. And then one more, one more, one more. Let's get that last one. Delete. So these are all deleted now. All right, so those data sets do not exist. So just to recap how we upload files. So I go to my SAS user area, my private SAS user area, and I look for whatever file I created. So I created a file. Obviously, you created a file as well. So this is my MB stats file. So I'm going to right click here, or if you have a Mac, you do whatever you do in the Mac world. You use two fingers or something like that. I'm going to hit upload file and choose the file I want from my computer. And see, I just downloaded this. So Snow Cars 2 is here. And it shows that it's an Excel file. Hit open. And I hit upload. So this will be uploaded to my MV stats folder. So let's just check MV for multivariate stats, right? And it should be here. There it is, Snow Cars 2, but it's an Excel file and I need to convert it into a SAS file. So I'm going to right click here and I'm going to hit import data. Import data converts it into a SAS file. And right now it's going to save it in the temporary library work and it's going to call it import, which I don't want. So I'm going to change the names. Remember, everything is saved in a library in SAS. So I'm going to change it to my library MV stats. And I'm going to call it, what did I call it there? Still call it Snow, I don't know, Snow Car 2 or something. Oh, we'll see. Let's call it Snow Cars 2. Snow Cars 2. I think it's Snow Cars. I mean, you don't have to do the underscore, but I just want to. I mean, actually, you kind of do when you're working with it, because if you don't, the program will mess up. So it's better to do this. So you see everything's changed now, right? MV stats, Snow Cars 2, and I hit the little running icon. There you go. So you see the data are in my folder: car, day, rural, snow, activity, and subject. All right. So actually, let me go back for a second here to the data set and show you what all this stuff means. So let me go to the other, even again, this is a different data set. I just forgot the first row there. So the subject, each person, this is what we call a long format. You can get data either into wide format or the long format. In the wide format, each row represents one participant. In the long format, each participant has multiple rows. So these different rows represent different days of data collection. So there's 3 rows per person. So that person had data collected on anxiety on day 1, day 2, day 3. This person had experienced snow, because it's 1 is snow and 0 did not experience snow during that part. So you see their anxiety went up from 35 to 37 to 40. They do not have a so-called snow car. So I coded that 1 for snow car, 0 else. or non-snow cars. So maybe you have a rear wheel or a front wheel drive car, so that they get a zero there, and they live in an urban environment because one would be rural and urban would be not. But notice how these don't change, right? These are kind of fixed for them, but what changes is their anxiety, right? And then this is my identifier to show that the data occur over 3 days. Now, I could have had the data in the wide format, then I would have to use some kind of a transpose function in order to change it from wide format to long format. We did that the other day, so I don't have to repeat that here. So again, let's go back to our program. So we see that we have car, day, rural, and they all show up as numerical. Really don't have any labels to them. These are just the auto-generated labels. All right, but we have our data set. And if we look under our MV stats folder, we have snowcars2.sas. So the SAS files have this long extension .sas7bdat. There's other ones too, but yeah, you'll see that if you download files. I really don't need this anymore, so I'm just going to delete this. And it'll ask me, do you want to save? Don't save. But sometimes you may want it to save it. I don't know. It's up to you. All right, so let's go back to our lecture notes and let's continue on. Onward soldier. So that's our data set. So upload, we did that. Format the data so that we have value labels for our discrete variables along with labels where necessary. So here's the SAS formatting code. So to format in SAS, so one of the drawbacks versus how easy it was with SPSS was you could do these right in a single procedure, right? You had some kind of a procedure, a data statement, and then you can do all the formatting there. Here in SAS, you create the formats first with this proc procedure format, and you create these just very, very general formats that you can apply to any data set. So for instance, here I use proc format, and I created the format for cars, for snow, and for rural. But I put FMT kind of car format, car FMT, snow FMT, rural FMT. And what I did was I took these numeric values. So for that, the data set included numeric values. Sometimes the data set will include these character labels like snow versus regular. It depends on who's introducing the data, right? So here I have 1 and 0. 1 was snow and 0 was regular. So I'm changing 1 to snow. So basically I'm creating a character variable out of a numeric variable. And that's because I want these labels to show up, right? I want these labels to show up. You could do whatever you want with them. I didn't capitalize. I probably could make it nicer. If you're a neat freak, you could do that. And for snow, we had 1 is snowed and 0 did not snow. And then for rural, we have 1 is rural and 0 is urban. Okay. And then we're going to create a new data. So let's actually do that first. Okay. And then we'll go back. So here's the format. Okay. So you'll see this format statement as usually you have to end with run. I'm going to go ahead and run this. So it just creates this generic format statement. No errors, thankfully. Some notes, but no errors. These are the notes, right? 4 notes. Yep. So I created these formats. So these formats exist now, so I can use them. So the next step I had here was to create a new data set, snow cars, and add the formats to the data set. And we're going to also label anxiety as state anxiety. So here's a SAS code. State versus trait. A trait anxiety is something that you either are born with or you developed over time and just is always present, omnipresent. So we're going to create a new data set. When we create a data set, we have to give it a name first. So this new data set will be located in my MV stats in my library, excuse me. And then the data set will be known as snow cars 2. What did I have the first one? Or did I already use that? Maybe I already used that. Let me make sure I did. Okay. Snow. Did I already use that? Let's see. What did I call? Oh, so I did I already use that? Let's see. I think I mislabeled it, right? Mislabeled it. Yeah. So let me just make sure that, see, I already called it Snow Cars 2. So I'm going to rename this. Let me just rename this so I don't mess it up. Or I guess I could just set it as snow cars 3. Oh, what mess I made here. Let's see. I can rename it. Okay, let's see if I can rename it. Can I rename? Yeah. Snow Cars 1, just so that it's consistent with what I have here. Rename. All right, so now it's renamed. All right, that makes sense. Okay, so I just renamed it. So the just remember that I renamed it. Okay. So in case you're running this, you probably want to change this to, yeah, well, I have it here correctly. Okay. When I uploaded, I should have just saved it as Snow Cars 1. All right. All right, so let's take a look at this now. So we have data, my library, MV stats, new file will be called Snow Cars 2. I set it so it's based on Snow Cars 1, right? See, that's what I mean sets. This is the original data set, Snow Cars 1, and we're going to create a new data set called Snow Cars 2. And there's a semicolon after each. I said add a label. So we're going to label anxiety as state anxiety and within these um, single quotation marks, and then there's your semicolon. Now I apply the format to the variables. Format snow as snow format, period. You got to put that dot in there. Car as car format, dot. Rural as rural format, dot. And then have my semicolon. Okay, let's just give that a shot here and see if that works. See if I didn't mess up somewhere royally along the way. All right. Here we go. So we have everything's here. Let's see if it works. All right, cool. We'll see the data. I have day, rural, urban. So I don't know if the format's applied or not. One way to check that would be to run a frequency or something else. I'm just going to run a proc freak, right? Proc freak data MV stats snow cars 2. That's my new data set. And I want to have a table for snow, car, rural, and day. Let's just see what they all look like. Let's check it out, see if this worked. And you'll see, okay, now the formats did apply for snow. We have did not snow versus snowed, and there's 9 in each. Car regular versus snow, there's 9 in each. Everything works out really well, right? Urban versus rural, 9 in each. And then we have day 1, 2, 3, 6, 12, 18. Perfect. Yes. So everything worked out. Day, I didn't have to label them because I didn't want to label them, but you could if you want. All right, cool. You could also run, the proc print to check your data. This will just actually print out the entire data set. There it is. So you can do that. Shows some nice stuff here. Look, although it snowed, did not snow. Everybody, depending on what one person had in the data. So it's beautiful, isn't it? It's absolutely gorgeous. Absolutely gorgeous, as they say, wherever they are. You ever wonder when people say, as they say, who are they? There's like, I think I envisioned this table with they sitting behind it, the global they. All right, so run procs. Okay, let's oh yeah, this is not right. Okay, next step is to let's see, what are we doing next? Okay, we're gonna just we did that. All right. Next thing is to run our proc mix. So this is what we're here for, is run proc mixed. And proc mixed is our mixed procedure. Our data set that we're using is MV stats dot snowcars 2. One thing we should do is we have to talk about our classification or our grouping variables. We have, or the variables that we're going to create dummy variables from, whatever our classification variables are. We have subject, day, snow. So subject is our participant variable. Day is our day. I don't have any reference category, but I could put reference the first. You can see second versus first day, third versus first day, etc. But snow, I used the reference as did not snow. Now, here's the interesting thing. When I was first writing this out, I remember everything was 0 and 1, and I figured, okay, well, the labels are just going to be labels, kind of like what you do in SPSS, but that's not the case. Okay, when I did this formatting, it actually created new values for, we talk about a sample space. These are the values of the sample space. We talk about a function generating, converting the elements of the sample space into numbers. But here I went kind of backwards, took the numbers and created these different elements of our sample space. So I had originally had the reference as 0, for each of these, but once I made this change, I had to change the reference to the actual code. So the reference here would be did not snow for snow. So that what we want to know is what's the impact of it snowing versus not snowing on change in anxiety. For car, we have the reference as regular. So we're looking at this impact of having a snow car versus a regular car on change in anxiety. And the same with rural, we want to see what's the impact of living in a rural area versus an urban area on on your anxiety. So that's kind of cool. But before I had done the formatting, I would have done zero for all of these, and that would have worked fine. But I want to have these because when I produce plots and stuff, I want it to have the actual labels. Okay. So our model here, we have model. So we have all our variables. We have snow, car, rural, day. So days are a repeated measure variable, right? One, two, three. And then we do these interactions like, okay, because we want to know, is there an impact of having a snow car on versus not having a snow car on change in anxiety. So that's what we're looking at here. And same with whether it snowed or did not snow, or whether one lives in a rural or urban area. Then we get our solution. I also changed our way of doing degrees of freedom. And this method is more amenable, or I shouldn't say that. It's more friendly to smaller sample sizes. We only have 18 individuals here, so I just used a method that was better for smaller sample sizes. Repeated measure is day. We have subject, and then we have, in terms of this is in terms of the correlation structure here. I use compound symmetry. Maybe I could have used AR1 as well, autoregressive one, but you can change it depending on what you want, right? For the correlation structure. I talked about that when we did the GEE lecture. And then I have my run statement. So let's go ahead and take a look at this here. Well, here's this. This is the one. Yes, this is it. All right. So let's go ahead and run. Maybe we can try the comps. See if the other one changes it a bit. I do this run, and I just get a lot of data showing me, my different levels of my class variables. And what I'm really interested in, I get these log likelihoods. I get also iteration history. It's trying to has some criterion that it wants to fit in order to say, hey, we've got to stop here. Let's see. So these are some of my fit statistics I could use. Like I can compare nested models that are nested, meaning there's one, there's like one parameter I set to 0 at some point, but basically the model is the same. Use this 2 log likelihood different minus 2 log likelihood. I can use the AIC, BIC. These other ones are for comparing models that are not nested. And that's really cool. You can compare like totally different models there. Oh, let's see. Well, now this is complicated because there's so many different levels, right? We have snowed versus did not snow. So this is comparing snow to did not snow. You just get your parameter estimates. So we see that this uses a t-test, and this is a significant effect of whether it snowed or did not snow on anxiety. So if it snowed, the estimate is positive and significant, right? There's an increase in anxiety with snowing. But before we look at those, we have to look at our interactions to see if they're significant. Like for instance, here we see that the snow, actually I have a 3-way interaction here. Right? Let me actually, I added a 3-way interaction here. This is something I want to do, but let me take that out of this for a second. I forgot that we weren't there yet. We weren't there yet. So let's go back here and take out that 3-way interaction. I see it. Okay, car by snow by day. All right, let's get rid of that right here. Let's go and rerun this again with just a 2-way interaction. Okay. One thing I added here too is the store model fit. This stores some statistics. You can't do anything to this that will allow me to use what this is, this Proc PLM that'll let me plot data. There were different ways to plot the interactions, but I want to be able to plot the interactions so we can analyze them. Because when you add interactions, unless you visualize them, sometimes they're very complicated to run. So I'm taking away that 3-way interaction. That was for later. All right, so this is just with the 2-way interaction. So we look at the 2-way interactions and there's nothing significant here, right? nothing significant. So inter two ways, so day by rural, uh, etc. None of these are significant. You'd have to read through all of these to understand what we're doing. So this is, you're always making some kind of a comparison. Here's nothing significant here, nothing significant. Since there was nothing significant in this model where we have two-way comparisons, anytime there's nothing significant in an interaction, you go back and look at what we call the main effect. So we want to see, is there a main effect for snow? That was the only one. I would actually say there's two. There's snow and car. The reason I'd say is two because we have a very small sample size. It's 18 individuals. So instead of using a p-value of 0.05, I'd use a p-value of 0.10. And if we look at this with this new criterion, when we're comparing a snow car versus a regular car, you'll notice that there's a negative effect, right? There's a negative effect, which makes sense. People who have a snow car will probably be less anxious, right? Be less anxious than people who have a regular car when driving in the snow, okay? So that's 0.0203. And you can also say that this is significant too, right? Because it's less than 0.10. And this is showing us that this is comparing whether it snowed versus it did not snow. If it snowed, anxiety increased because it's positive. However, there was no interactions that were significant here, so it's kind of a bummer. But we can also take a look at plot some of these interactions, and that's what I'm going to do next. Let me go back to the notes, say that I want to stay consistent with what I said I would do. All right. So this is just all the two ways. Plot the two-way interactions. We're going to use, so what I did here versus here, I didn't have the store, right? I didn't have the store model fit, right? You notice that it was not, and this was just basic analysis looking for effects, but it did not include the store statement. The store statement allows me to store some data so that I can actually draw plots, right? So I did that and we ran that with the store statement. And now we're going to plot using Proc PLM, and it's going to base everything on the model fit. So this is basically we're saving model fit data, and then it's going to access the model fit data. So this is a Proc PLM statement. It's not the same as some of the other statements, but I found it the easiest way to do these plot. So we're going to ask for an effect plot. We're looking for an interaction where our x-axis, so you think about a graph, x-axis is the horizontal axis, will represent day. So day, remember there are 3 days, day 1, day 2, day 3, when we were measuring anxiety. And we're going to slice it by snow. So you'll see different levels of snow. And then we're going to also run one for day by car, and then one for day by rural. So we're going to get these nice plots. So let's go ahead and take a look at those. Since we already ran everything, the data set is already stored, and we'll go here. So this is what we're looking at, okay? So I'm going to go ahead, but you notice how you have to, in SAS, everything has to follow from everything else. So like you can't do the formatting unless you do the proc formatting first. You can't run the proc GLM unless you stored the model fits, right? You can't do it. So you have to do this. So now I run this area and check these out. I get nice plots here. All right, so this is my anxiety. Now, again, none of these were significant, right? But here's my anxiety plot looking at snow. Even though there was differences, they were not statistically significantly different, but we see that anxiety was higher for snowing versus when it did not snow, right? This is over the 3-day period. And this is for whether one drove a regular car versus a snow car, blue is snow car. See, their anxiety was lower than if they drove a regular car, right? And then this is for rural versus urban. This one kind of looks like it should be significant because you see this crossing here. But this is for the urban folks, right, versus the rural folks in terms of anxiety, which is kind of is weird how it worked out. So it seems like over time they were more anxious, the rural than the So it kind of negates, but it's not significant. It would have negated my hypothesis there. All right, so let's go back and we're going to run. One of the things you want to do when you do interactions, you don't want to just do a two-way, probably want to do a three-way. Now, I try to do every possible three-way interaction, but I couldn't. The system wouldn't let me run. It says, we can't get a solution. It goes on to infinity, so that's not good. Right, so I'm going to go back here and see what I had plotted. Plot the three-way interaction for car by snow by day. So I want to know if there's a difference based on the type of car you drive in either snow or no anxiety in either snow or no snow condition. Okay, so this is a three-way interaction. This is where the plotting is extremely important. So I just have to add that interaction to my code. So you see I have anxiety equals snow, car, rural, and day. Then we have car by day, which is the same thing we had before, snow by day and rural by day. And then I have car by snow by day. All right, so this gives me that three-way interaction. So I'm going to do car by snow by day. And I love how in SAS, if I'm going to add an interaction, all I have to do is go, it's really simple, right? Car by snow by day. There you go. So that's all I have to do. And this adds this interaction term. So basically, when an interaction term is just multiplying things together, that's why it's the product, right? So I take your score, whether you have a car, like say you have a car that's a snow car, you get a one, and it snows, you get a one, and whatever the day is, one, two, three. So on day one, you'd have one times one would be one. On day two, you'd have one times two, should be two, and then day three. So it's just multiplying them. It's not doing anything else, right? That's an interaction. So let's run this. So it'll create a new little file for us, right? Gives us a new file. And let's take a look at this interaction if it's significant. So we do have a, wow, we do have a significant interaction. So this is comparing, these are the comparisons being made. So here it's comparing whether it snowed and you have a snow car to whether it snowed and you had a regular car, did not snow and snow. It's making comparison to all these three, just as this is making comparison to all these three. And this is making a comparison to all these three. So it's making all these cool three-way interactions. One of them was significant. And it was whether it snowed and you had a snow car. So it seemed like because it's negative, there was a reduction in anxiety. And that's what we were hoping to see. Because these are all significant, I don't have to interpret any of these individuals, any of these three individuals. So I kind of can ignore the rest of this model. I don't need that anymore. The interaction supersedes everything. It always supersedes everything. So now I'm going to go run, because again, this is like, look at that stuff. I mean, it's really hard to figure out what all this stuff means. What I'd probably do if I was doing a paper with this, I would cut out all these comparisons and put like little bullet points, say snow was compared to did not snow, because this is very messy looking, okay? So I'm going to go ahead back to my code. And the next step I said in our notes was we're going to run proc PLM for the three-way interaction. So we're going to create a figures for the different curves based on whether or not one owns a snow car. So this is basically it's going to give me day by snow. So we already had those, right? You had day on the x-axis and two separate lines to whether it's snow to see what the anxiety was. But now we're going to have two plots. So we're going to have separate plots for your car, whether you get a snow car or no snow car. If you had three levels, like say there was a two-wheel drive, SUV, and then a snow car, if there's three levels, you'd have three plots. So this is cool. Okay, so this is going to allow us to see visual. You got to have plots to visualize interactions. At least I do. All right, so here we go. We're going to run the proc PLM. Again, we're using the model fit. And we're going to get this interaction. That's what we want is the interaction effect, right? So we're going to run that. Look at that. Beautiful, huh? So now I'm looking. So that's why I labeled everything. So it says car equals snow. Car. Now it's funny. I might have in my work with clients, sometimes they'll say, "Oh, can you get rid of the car equals?" I'm like, some of these things are really, it takes a lot of brain power to get to figure out what these things are. I could go through the code and figure out how to suppress car equals. mean, it can be done. Oh, no, we don't like the zero underneath at the end here to, just make a, whole number or whatever. There's a lot, change the title, etc. You can do all kinds of things with SAS, but this is what we wanted to look at. So we see that this interaction was significant. You see, when one has a snow car, there's a decline in anxiety when it snowed versus when it did not snow. I mean, there was decline in both, right? But there was a little bit of an uptick here for it did not snow. But if you have a regular car and it snowed, look at anxiety increases, right? And if it did not snow, anxiety decreases anyway. But you can see what's going on here now. I mean, I could also, of course, I'd want to get the values and I can actually write out a nice report for this. That is pretty darn cool. So that's what you want to do when you're running these kind of analyses. You want to go and plot everything so everything makes sense. Because you're always having to present this to somebody else. All right, cool. Let's go to the next thing. Do it again, but with a second data set. All right, so we're gonna use a second data set here. I think we're gonna call this something. We're gonna call it something else. I just I played around with the points a little bit here, created a second data set. So this is the way you'll do it. So you're gonna copy this. Again, it's an Excel product within Microsoft Excel, which is a Microsoft product within a Microsoft Word document, so they all communicate. I'm gonna hit copy. I'm going to stick this in an Excel file. Excel file. Here. Hey, sorry, so here's my Excel file. Everything's all set and ready to go. Maybe I'll save this as, what do I save it as? Save as, so, that was a data set. Uh, I think I call them snow car, right? Snow car 5. Let's call it snow car, something totally different. Snow car 5. All right, so I can close this and go to SAS. See, I'm doing this for you guys over and over again so you can follow me and you can figure this out because I'd eventually like you to not have any issue with this at all. So I'm going to put it in my MV stats file, which I created, right? I'm going to upload the file. I'm going to choose my file and I had it on my desktop under this course and I called it Snow Car 5. Open, upload. It should be here now. Snow Car 5. Next step is to pausing. I think it was at Dora the Explorer, they pause and wait for you to answer, right? We're going to do an import data. Again, I don't like that it's in the work temporary library, and I don't like the name, so I'm going to change it. Put it in my MV stats library, and I'm going to call it, what do we call the other ones? Let's see, we call them Snow Car 2, right? Let's just keep this Snow Car 5. All right, just keep it the same thing. Snow Car 5, except for now it'll be saved as a SAS file. So I changed everything, but I have to run it. So I run, and we have everything here. Everything's good. All right. So I can close this. I don't need to save this. Don't save. Let's go ahead and first thing we have to do is format everything. Okay, we have to format everything. So you see, by the way, you see how I have a lot of code for this course. That's just the way coding works. You can create a separate code sheet for whatever program file for whatever you're doing. Since this is a course, I'm keeping one program file. If I was doing separate projects for different clients, I would use a different file for each client, but then I'd keep it. I'd keep it. And let's see, so let's go ahead and start. Well, we already have the format, so format's not changing, right? We have the same variables. This format statement is fine. So let's go ahead and create our new data set. Let's call it, well, we have this one called snow car, not snow car. So we're going to call this, let's create this new data set. Let's just copy this and let's see. Just use this. Why redo it? Okay, so we're going to call it snow car 6. 6, right? Since we did snow car 5. It'll be stored in our MV stats library. Okay, and then we'll set it at snow car 5, right? Oop, snow car 1. Control. What did I do here? Okay, hold on. What did I do here? What did I just do? Okay, snow car 6 based on snow car. Just press some wrong buttons. Snow car 5. Okay. We're going to call it anxiety state, anxiety. Everything else is the same, right? We're just, because we really didn't do anything. I just changed the data set, changed a couple of numbers around. I didn't change anything else. So this still applies. So I'm going to create a new data set called snow car 6, right? Okay, there's my new data set. Run proc freak to see if everything worked out okay. So this is just using my new data set. Okay, my new data set, and I just want to run just to see the frequency distributions. Uh-oh, snow car 6 doesn't. Oh, I see what I have. Let's check. No, what's called? What did I call it? Snow car 6. I have snow car 6. Yeah, very sensitive. Snow car 6. Okay, so here's my frequency. Everything checks out. Nothing's changed here. It should be the same. Again, everything uses the code that I used in my formatting statement. So I have really nice, this will look good if I'm presenting it to somebody. Yeah, I can doctor these up a little bit, but at least, you have labels here. Maybe use capitals instead of lowercase, whatever you want to do. All right, so next thing I want to do was run the proc mix statement. And I'm just going to do two-way interactions, right? I am going to save my data, save these, whatever these estimates are in my model fit statement, under store model fit. Everything else is the same. Nothing is changing at all. I just have all the two-way interactions, right? As my reference points for snow, for car, and for rural. So that even though this class statement creates dummy variables, right? So it creates dummy variables, but I'm telling it what the reference is because it may not use that reference. It may use the reference as snow instead of did not snow. And I want it to model what's the impact of snowing versus not snowing. I don't want to model what's the impact of not snowing versus snowing. So I have to tell it what I want. So I'm going to run this. As usual, I only highlight what I want because otherwise it'll run the whole thing. All right, so we look now at the two-way interactions, see if there's any significant effects. Nothing, zilch, nothing. I'm just looking at p-values. Still, there's an effect for snow. Again, since there's no two-way interactions that are significant, we still look at the effect of our variable snow. Okay, let's go back to make sure I did everything right. Did I do anything wrong? Actually, I did not do that correct. See that? I used the wrong data set. How come you didn't catch that? Talking to you guys. 6. I was supposed to use this data because it looked too familiar. I thought it would, okay, use the wrong data set, so let me use the correct data set. There we go. Yeah, I figured there might be some significant interactions because I changed the data to make them look like there were significant interactions. So we have like car by day, we have a significant interaction here, right? So if car is right 1, right? So this is 1, so car is 1, and with time you'll have a significant effect. So if car is a snow car, Well, actually, it's a snow car. Huh. So we're kind of looking at snow versus regular. Interesting. Again, it's hard to interpret these interactions until you actually visualize them. But this is significant. This is significant, right? I'd rather just wait till I see them. And I don't have a three-way interaction in here yet. So I can actually plot these two-way interactions. Let's plot the two-way interactions, see what they look like. So this is the plot of the two-way interactions using that Proc PLM. So this is whether it snowed or did not snow on anxiety. So you can see there was, I mean, you know, they're just almost displaced. So it's not, I mean, they're just like basically almost have the same slope, almost. This is a little bit more quadratic. Here you have a difference, snow car versus regular car. A lot less stress for those who have a snow car versus those who have a regular car. It's increasing. And here we also have a rural by day, where you have those who live in the rural area seem to be more stressed, but I don't know if it's significant. Let's go back and was the rural by day significant? Let's go to the results. It shows me those results. So that's one of the things I don't like about SAS is that I have to keep on. I could save this, which I didn't do in this case, but I could save it and then run it. But I mean, I'd have to save it as a different window. But I wanted to look at that rural by day, so that wasn't significant. Even though, I mean, this is close, right? 0.106 if I'm using a p-value of 0.06, but that's I point 10, but it's not significant. All right, but that's still interesting to look at. So let's go and add that three-way interaction in here. So what did we have before? Was it, I think it was, what did I do before? Let me see. It was car by snow by day. I can just copy this. Copy car by snow by day. And it's here. Control V, car by snow by day. All right, let's run that. Three-way interaction. Just see if that's significant. Doesn't look like it is. Well, I would say this one is because again, if we use an alpha of 0.10, since our sample size is only 18, this could be significant. So let me go ahead and run this figure. We created the data necessary for the figures. Here it is. Again, I didn't change anything, right? Well, let me, yeah, the three-way interaction. Okay, so let's plot that. So it looks very interesting, right? So for if you have a snow car, snow seems to be, well, if you have a snow car and it snowed, there seems to be a reduction in anxiety over time. If you had a regular car, if you had a snow car and it did not snow, it doesn't really do much, some minor variations in anxiety. Here, you have a regular car, and whether it snowed or did not snow, it seems like anxiety is pretty high, right? A little bit higher. So if it snowed, right, than if it didn't snow. So you need these figures in order to interpret your interactions and to present something well, because people are gonna, if you're presenting to say at a conference or something, they're gonna like you just say, and I see this a lot with students. They'll go, just give me, here's our results, and they'll do something like, just throw this here, do this one again, right? And they're talking, and here are our, where is it? And here are our results, and they'll show you a table like this. I'm like, what in the world does that mean? Any of that mean, right? So, you know, I, it's a really confusing, and you don't want to see that, especially they'll put the numbers in the table that are really small. So I'm squinting looking at that table, trying to figure out what's there, when instead, if you just run something like this and produce some beautiful plots, everything makes sense to me now. Oh, okay, I see what's going on, right? So you use the graphics in order to enhance the numbers and to certainly to communicate them to others and also to understand it yourself. I understand it better when I looked at these numbers, even though these data are made up, I made up these data, but I still understand better by having a graph figure. All right, who's here today? Hey, a lot of you guys are here. Awesome. So everything okay? Any questions for me? So one thing I want you to focus on getting your semester project done. Okay, that's key now. Okay, so I mean I know this is the seventh week, with like 15 weeks, so we're almost halfway, believe it or not. And next thing you know, we'll be wearing short sleeve shirts outside rather than just inside. It's gonna be nice and warm out there. So that means the semester is progressing. So I need you to work on that. Obviously do the projects that I'm giving you here. Again, these are for experience. They're experiential, but also do your semester project. So don't forget this Thursday will be another video like this. I won't be here on campus on Thursday doing it, but I'll have a video for you to continue this. This was awesome stuff, wasn't it? I mean, this is awesome. So now you can do something really cool and answer some beautiful questions. The key then here to remember is that what you have to do is you have to structure your data appropriately. So you saw that I had the data structured so that we could do this analysis, right? I had it structured in the long format, right? So everybody has multiple entries and it's all done, horizontally. So one participant have multiple entries rather than, the wide format where you'd have like day one would be a variable, day two would be another variable, day three would be another variable. So that's what we do when we use the wide format. But so that it's important for this analysis that we use the long format. Yeah, and then we're going to keep on getting into some neat stuff. I hope this was helpful. I want to thank everybody for being here today. Okay, thank you.
Thank you.